Hello, everyone, and thank you to be here. I'm very happy to thank you, the organizer, because they made my day so easy, and they picked me up from the airport, so it was everything super easy and friendly, and I have a notification here. So you can see that my talk is now, so I'm ready to go. I'm Gianluca Arbezzano, I come from Italy, and I work as a site reliability engineer at InfluxData. I like to blog, so if you are good readers, I try to write once or twice a month, not that much, but still something. And I'm a Twitter user, so I like to interact with you and everyone about DevOps and automation and development. So reach out if you have any questions. I'm gonna share my slides later on. Other than that, I like to make really great dirty hacks. This is kind of a requirement when you do DevOps. I grow my vegetables, so I have a garden where I grow tomatoes and salads, so I'm very excited because the season is just gonna start. In Italy, we just had some bad days, but it's gonna get better, so I'm very happy to come back on my garden in a couple of weeks. I like to travel for fun and work, so when I can join them together, that's very great, so I'm very happy. I like to cook, so this is me when I was in Dublin making gnocchi by myself, trying to survive in a new country and getting better with my grandmother's skills and learning. I like to travel, so this is us, the InfluxDB team, during the Whole Hands this year in Palm Springs, California. This is why I like to travel and work and join them together, because we had some really cool days over there. This is a LinuxConf in Cape Town. You can see the community is vibrant over there. I was there a couple of weeks ago, and the Linux community is great, and they develop a lot of great stuff over there. So it's a really great experience for me. And this was me in Cuba, and as you can see, the horse is way bigger than myself, almost bigger, because that was my first horse trip that I had. So they give to me a really cool and friendly horse that was, I was used to move around to Cuba. And this is the slides when I'm gonna say to follow me during my journey as a SRE and DevOps at InfluxData. Today, we are gonna learn about what we are learning and what I learned since 1 year ago when we started to develop the new version of our SaaS offering. So this is how InfluxDB looks like today. We have a couple of tools. They are all open source that we use, that you can use to build your monitoring system. It can be a monitoring system for DevOps, so to instrument your servers and your application, to make pretty graphs, or and dashboards, or to do alerting. But other people or other companies are using our stack to do IoT. So what we do, we manage time series data. Time series data are all those kind of data where times matters a lot. And in DevOps, we have a lot of them. If you think about logs without timestamp, they don't really mean anything. If you think about CPU, it's really important the seasonality of the CPU over time. If you don't have a reference of when a CPU is growing, it's almost a useless information. And that's what we are dealing with at InfluxData, time series data. In order to do that, we made a database that it's very efficient to store and manage these kind of metrics. This is InfluxDB. You can find it on GitHub. After that, we realized that having a database was good, but was not enough. People was asking us for more. So with the community, we developed Telegraph, that is a collector that you install in all your servers, and it starts to get metrics out from your infrastructures. It has more than 200 plugins. You can do almost whatever you want with it. You can scrape stuff from MySQL, from Docker containers, from Docker itself, from MongoDB. It also exposes InfluxDB API layer compatibility, so you can write your stats in your localhost, and it's going to collect and forward them to InfluxDB. It's a very flexible tools that can be used also with other sources. So you can take stuff from InfluxDB and collect them and push them to CloudWatch or AWS, or you can do the opposite. You can grab stuff from AWS CloudWatch and push them to InfluxDB. So there is a lot of flexibility going on, and it is not tied to InfluxDB itself. Other than that, we developed Chronograph. It's a UI system. If you know Chronograph, you probably know that InfluxDB is well covered by it, but you can use Chronograph as well. And Capacitor is our proactive monitoring tools. You know that when you have data, but you don't know what to do with them, they are pretty useless. So Capacitor is our post-actor that does alerting or downsampling, or it applies machine learning algorithms to the metrics themselves. So this is our stack, play with it. But this is not about our stack. This is about our journey from doing DevOps in a way and learning how to do DevOps in the next way. So just because it's morning, so we're gonna scratch a little bit our arms. This is what I think when I try to define DevOps. DevOps are people that likes automation, and automation likes code, but YAML is not code. So who agrees with that? Raise your hands. Just to understand the mood of the room. So less than half of the people. So half of the people are gonna really dislike my talk, but I hope you're gonna take something out from what I'm gonna say. This talk is inspired by a true story. So this is not a joke. All this stuff really happened. So if you have any questions or you are going through our same trouble, just stop me. I'm gonna be around all day, and we can have a chat about what we did and in much more details. Red slides, red background, Kubernetes. This is a reasonably good story I learned when I asked somebody if they are using or not Kubernetes. You heard about Docker, and you use Docker. Everyone uses Docker for their CI environment because it gets everything easier. You can start containers, you can spin up new environments, and you can destroy them. And at the end of your CI, everything looks almost easy and clean as it was before. So this is there. We use it, we know how it works. But when we move around, when we go to a bar, to a coffee place, we heard that people speak about Kubernetes. So if you go in a bar and you get a receipt, probably the receipts come from a Kubernetes cluster, because that's how it works nowadays. So you kind of get in the mood that Kubernetes is important, and you should use it, but you don't really know what it is. At some point, you start to grow, your company is doing great stuff, and you onboard new people, and these new people used Kubernetes in the past. So you start to get in the mood that maybe something is gonna happen. And in a couple of weeks, you find yourself and all your company moving everything to Kubernetes. And the experience looks like this one. So this is not a joke, this is us moving to Kubernetes. So this is how it happened. The best way we had to learn how Kubernetes works and how to operate with Kubernetes is to make our hands dirty. And I don't mean our hands as a DevOps or as a sysadmin. I mean our hands as a developer, as a company. So we took the developer, we put them in front of a kubectl, and we say, type something and let's see how it goes. So this is how we started. We spin up a new cluster, and we ask everyone to play and break. The best way to learn is to feel confident about breaking stuff and doing your work. So bring developer in the loop, make documentation, give them good books to read, and drive them to their journey, because at the end of the story, the goal will be to have them running Kubernetes and not you. So that's it. A very good way to start is to deploy your CI on Kubernetes. As we spoke before, Docker is a good way to have environment that you can clean up, destroy, and recreate in a very easy way. So CI can go to Kubernetes, because Kubernetes is very good at scheduling containers. So if you use Docker and you use Kubernetes, your containers get scheduled in a really good way. And Jenkins, for example, has a good Kubernetes plugin that you can use to say, okay, every build should go in this Kubernetes node, and you are gonna learn something from something that you already know, like the CI. Another important point about having CI is that nobody cares about CI until it breaks. So that's how it works. You move the CI there, everything starts to work well, but when you have a problem, you are forced to get there and fix it. if you deploy something that you don't care about, you are not going to fix it, and you're not going to learn anything. So if you're going to take your journey through Kubernetes, do something that will help you to care about what you are doing. I learned that CI, I learned on my, from my experience that CI is a good way to start. Another good way is to force your developers or to help developers to run their code in production. And I'm not against developer. I'm a developer I was a developer way more become a DevOps or a system administrator and SRE. So I come from a very different background. So if you think that the DevOps are system administrators that are learning how to code, you are making a mistake. DevOps are just people that likes automation and likes to have a different kind of problem to solve. So I was a developer. I started as PHP and WordPress and all that crap, and at some point I decided that it was not for me. So I got the chance to help some customers and some companies to move to the cloud, and that's where I started to think about automation and DevOps as actual problem to solve. So run your code in production. If you are a developer, ask your operational guy to help you to understand how your DevOps works, how your environment works, and if you are a DevOps or operational person, helps your developer to feel confident, because that's how you join people together. Make new friends and make them confident about production. That is not that weird and scary stuff that breaks all the time. Another good lesson we learned during our journey is that YAML is not the unique way to think about automation. So what we started to do was to migrate out from the YAML specification or the JSON specification to something that we know more and that we can control better. In our case was Go, because we are all Go developers, so we started to think about, okay, but if we stop to use YAML and do template engine and rendering stuff, and we start to actually code what we need, maybe our day is gonna be different. And I think it's different now. So along this presentation, I'm gonna give you some example about what we did. So first of all, we have this gigantic YAML specification that says, okay, I need one pod, I need one deployment, I need a stateful set, and all this kind of stuff. We made a tiny CLI that is able to migrate YAML to actual code. If you think about Kubernetes, you need to think at it like a server, a service that exposes API. So whatever has API has a client, and a client or an SDK has objects that you can use. So in our case, we was using Go object, but you can use Python object or PHP object. So we migrated YAML to actual code, and something started to happen. We was able to embed this code inside our application, and we was able to stop to render gigantic YAML with parameters inside. So our lives was getting a little bit easier, and we was able to make some tests and to check whatever was gonna be deployed. We still have some manual tests that we need to remove, but at some point, I hope we're gonna be strong enough to just remove the YAML from the spectrum. So we're just gonna write Go, we're just gonna write in a programming language that we like, forgetting about YAML. I didn't really, come up with this solution by myself. There is a really big movement that is called GitOps that does something similar. Not all the people are doing that with Go. Somebody is still doing the same with YAML, but as I said, I'm coming from the development side of the spectrum, so I like code. I'm sorry, and we all speak about infrastructure as a code, and has something that gives us a lot of power because we have version control. It's in a GitHub repository, so people can do review of what we do. But has code really means something, means code. And yeah, I put a link there. If you think that this has sense, you can follow up. There is a company, Waveworks, that is really into the GitOps stuff. Another lesson we learn is the secret of success. So I'm gonna give you really important tips, how to succeed. Don't be scared about writing your own code. That's it. infrastructure as a code, code is everywhere, write code. If you think that a workflow doesn't fit your company or doesn't fit a specific team, develop their best workflow. This is what I learned as a, in the DevOps movement. The culture is a learning culture, so we need to observe, learn, and code. If we think that we don't need to code because everything is already there and what we have is perfect, you are not observing your team enough. So sit with them, with your developers, and go through their pain and fix them. They're going to be friendly with you, and they're going to help you troubleshoot production outages at the end. Why Kubernetes is so powerful? Why everyone is using it? This is a question that I try to answer every day. Why Amazon is so expensive? This is another question. I think it comes back to the complexity. Kubernetes is complex. It has a cost to run it. AWS is a little bit expensive, but when I think about what I can do with code, I'm going to give you them all the money I have, because I can do VPC peering, I can set up complex network, I can connect them cross-region, I can do load balancing, and I don't even need to buy a cable to do that, or a rack. It's everything made by API. So if you think that those two stuff are too expensive for you, maybe you are not finding the right way to justify them. If you're using AWS or every other cloud provider and you find yourself clicking around in a dashboard and you think that that's automation, I think you have a lot to do. If you find yourself writing this code every day and you think that this is automation as a code, or this is a good way to justify Kubernetes, that's why it's so expensive. API are the keys for our success. So that's how a DevOps is able to create the best flow that developers and DevOps and operation are happy to use. Every third-party services, every Terraform or every Kubernetes develops and provides you API. This is not because they can do the kubectl for you. This is because you can use the kubectl as a getting starter, but when somebody asks you to do more, you can do whatever you want. That's something we learned, and that's why I think everything is an API. So if you think about Docker, it's made of a small set of tiny binaries. So if you think that Docker is just Docker run, you have missed a lot of points here. So Docker is made of a bunch of stuff. There is a Docker-D daemon that is a TCP server that exposes an API that Docker run, the command you do, just package a TCP request and sends the request to the socket or to the TCP endpoint. So there is already two binaries over there. And it always provides a REST API and the CLI. So everything you do, Docker pull images, Docker network create, it is not just a CLI. It has an API that you can use by yourself. And if you think that Docker-D is just a Docker-D daemon, that's another common mistake. Docker-D is just the API around, a friendly API around another set of tools. Containerd is the runtime engine. So Containerd is a tiny, tiny binary that helps you to manage the life cycle of a container. So when you do Docker run, you are starting a container. When you do Docker stop, you stop a container. You are managing the life cycle. So if you think about journald as a process manager, Containerd is like of the same, but for containers. And it is used by Docker to manage the life cycle of your container. But this is not enough, because managing a life cycle requires to actually spin up a container. But Containerd doesn't do that. It uses the runc API to ask to the runc CLI to start your containers. So if you're wondering who is actually starting your container, runc is the binary that is doing that. And you have all of them in your laptop, so check them out. Containerd is way more complicated, as you can see, because Containerd is that binary that looks so tiny, but it's really modular, and you can do a lot of stuff with it. It exposed a gRPC API, and and with this gRPC API, you can use it with Kubernetes or you can use it with Docker. So even Kubernetes needs to spin up containers. So you can use Docker as a CRI, as a container runtime, but you can also use Containerd or other solution. And we are allowed to do that because there is an API that gives us the ability to change the underlying runtime. And I think this is one of the secrets for the Kubernetes success, because it is made of layers, and those layers can be replaced. So if you're wondering why, in a couple of months, every cloud provider is now able to provide a Kubernetes implementation, it's probably because they just replaced all the layers that are not able to control with something that they have. So Kubernetes provides you a DNS server, and maybe AWS is using Route 53 over than Core DNS or Kube DNS. Azure is using their own. You can replace what you don't know about with something that you know, and still enjoying the layer of compatibility that it gives you. So Containerd is used in a lot of cloud providers to manage containers because it's tiny, it's easy to manage, and it doesn't have that all the complexity that Docker nowadays has when there is a orchestrator embedded and the cool API. If you just need a way to manage the life cycle of your containers, have a look at Containerd. And it is used by Docker. So same for Kubernetes. Kubernetes has a master, a set of nodes, and there is an API that gives you the ability to implement your flow. A Kubernetes node is made of pods, and when you ask for a pod, the worker gets the message from the master, and it pushes the message to the container runtime, Docker or Containerd on CRI-O, and that's the actual place where it's gonna start the container. The first version of our SaaS offering, we serve InfluxDB and all the tool chain as a service tool. It's still running, and it runs on a lot of AWS regions. And to develop that, back in the day when Kubernetes was that cool as it was today, we developed our own orchestrator for EC2. So we get a request that says, okay, I need a cluster in a specific region, and these clusters need to have 3 data nodes, 2 meta nodes, and 1 chronograph. So there is an orchestrator that gets that request, manipulate the request, reach to AWS, and provision the actual underlying services that we need, resources that we need. And this is made using Go. We use security groups. We use AC2. The architecture looks like the orchestrator-like architecture. So we have a master that is the brain of the cluster, and there are a bunch of workers that does the job. So every node has a daemon inside it that reaches to the master and identifies itself and says, okay, I'm here, I'm an InfluxDB node, what I'm supposed to do. And the master gives to it the information and the configuration, and it starts to provision itself. So something I learned along the way is we don't use provisioning tools like Chef or Ansible or stuff like that. We have these tiny Go binaries that starts with the user data of the AC2, and it asks for the configuration, it pulls the configuration, and it does the magic. When something breaks, we remove the AC2, we have the underlying volumes, so there is an automation that creates the new AC2, and the daemon asks again what to do, and it does the same with the old volumes, so the data are in the volumes. It's a very cheap implementation. It's easy because you don't have all the complexity to do Ansible, run, or whatever. But we are now running a couple of thousand of servers from a couple of years, and we're still happy with it. Other than AC2, VPC, obviously we use Route 53 because every cluster is isolated and every cluster has its own DNS, and it interacts in its own private network that is managed by the security group. Everything that goes to the outside uses the load balancers. So what is it really important to know is that we made all this stuff just using the API, because we do not think that what you can buy is what you need. You can buy something that slightly look like what you need, but at the end, your team is going to develop experience, is going to develop opinions, and it's our job to make them real. In this situation, we use Docker, but we use it not for the orchestration, because the orchestration side is made in the EC2 layer. So we don't really orchestrate container. We use Docker as a process management tool. So as I said before, we kind of use it as a systemd replacement. And the Docker API are really friendly, so it's very easy to do something that works without doing to go down to the C libraries. If you think about what you do when you do CI, if you use the Docker Jenkins plugin or something like that, you are using Docker inside Docker. And this is another easy, and a lot of people think that it's free and simple use case for Docker. But it gives you a lot of flexibility, because what you do, you create a container, you share the Docker socket from your laptop to inside the container, and from that point in time, you are able to speak with the Docker in the host, and you can do whatever you want with it. So that's how the Docker Jenkins plugin or the Docker Kubernetes plugin works, because every build runs in its own container, and the container shares the Docker socket, and from that point in time, you are good to go with whatever you want. When you stop the container, when you destroy the container, you are fine. Another good lesson that we learned is that a good user experience for operation is important. I'm a CLI guy, so I stay in the terminal all the time, and I don't like to browse around because I get scared about the internet. So I'm happy to stay in my terminal. But this doesn't mean that we are creepy and weird people that doesn't enjoy a good and friendly experience during the journey. Because it's important when you have an outages to be sure that your tools and your flow are rock solid and everyone can get them. I saw a lot of companies, and we still have them. We have a lot of weird scripts that are made in different languages, and they are checked out in some repository or maybe in some host, and you don't know what they do anymore, and you don't know when to use them. But this is a pretty bad user experience. So think about, if you are in operation, think about the idea to have a friendly experience that you will get a lot out from it. You will get an easy workflow, you will get a repeatable set of interaction that we can do. It can be a CLI. It can just be a unique and friendly CLI in the same language that everyone can kind of add their function to and their command. So the CLI will have an help function that will give you a little bit of context. It will have a documentation. It will have a man. So it doesn't need to be a React JS application that does cool stuff. The CLI is great, but take care about the experience you are providing for yourself, because that will make a gigantic difference under pressure. And we live under pressure. So it's not something that happens once a year. Another good way to bring developers and operation really close to each other is to start an effort where you troubleshoot your code and your infrastructure together. Nowadays, where everyone has a lot of third-party services that use, or you start to split one gigantic application to a lot more smaller application that interacts with each other, and you have more teams that does a specific application, and you don't have all the knowledge of all the system, it's very important to have a way to observe the system, to understand how it goes, and to monitor it. CPU is not enough. The memory usage is not enough, because I never got a call from a customer that called me and says, I can't buy because you're using too much RAM. Nobody called me and said that. The customers call me and say, I can buy because I get a 500 or a weird black page or blue page, and I can do whatever I'm supposed to do. So they call me with that in mind. Then they don't tell me that my CPU is too high and my disk is full. They don't really care. So why I should care? I shouldn't care, because we have automation, we are on AWS, we are on Azure, we have cloud providers, we have APIs. So if a EC2 or one virtual machine has problem, just put it out from the production pool and replace it with something else, and you are going to troubleshoot it later. So observability, instrumentation is important. Monitoring is important, but instrumentation is way more important because it is closer to the application. And you can't instrument your application or other application by yourself. You need to collaborate with people to say, okay, we need to know how many invoice this application made, because this is what the customer is looking for, and that's the metrics I'm gonna look to understand if the service is working. If it doesn't send any invoice, but it runs in 100% memory, this is a problem that you're gonna catch with traditional monitoring. But it's important to have a way to observe and to learn how a set of application works. And it's a good way to bring developers and ops in the loop, because the tools are really the same, because you need to do dashboards, you need to do queries in your time series, you need to do alert. So it's kind of the same feeling, just from two different sides of the spectrum. The secret is about how you combine data together. As I said before, nobody's going to complain if the disk is full. The people are going to complain if the disk is full and they can get the PDF. That's what they complain about. So if you just look for the memory usage, but you don't care about the number of logins you can handle or you are handling, no, there is no point to wake up during the night. So that's why aggregation is important. And aggregation is very hard. If you are doing alerting on one specific signal in your application, you are going to wake up with during the night with a lot of false positive, and you are not going to like the experience. So we have metrics. So we have CPU metrics, we have the number of logins, all these numbers distributed in times. And from my understanding, metrics are like a slap in the face. So it's 3 a.m. in the night, you have a spike, somebody calls you, you wake up with a gigantic slap and you say, okay, what's going on here? You wake up, you go to your laptop, and you are like sleeping again because you don't know where to look. If you just look at the metrics, they are not enough to understand what's going on, and you will miss a lot of time trying to figure out how to fix the issue. So if you're a smart guy, you start to look like a demon, like this guy. So you tail the logs, and you go really close to your laptop, and you say, this stream of logs is too fast. There is something wrong here. Or this stream of logs is so slow, I think somebody's wrong here. But this is not really the best way to troubleshoot. And this is not going to work when you're going to have applications that are replicated, maybe across regions, maybe across cloud providers, and when you don't have your production server. Yeah, okay, thank you. It was a sign that we probably need logs. So yeah, don't be like a demon. So we have better tools, better way. And they are not going to work in the nowadays environment where you have microservices. Wasn't the trigger. So you have logs, you have metrics, but they are not enough to build the context. So that's why everyone speaks about tracing. And tracing is just a different aggregation of points in time. So you have a point where your request starts, you have the point where your request ends, and your visualization tool is gonna connect the dots. You have a set of them because your requests are going through a bunch of services, and every service is like this line. And those lines are called spans. This is just another way to aggregate your, it wasn't aggregation either, to aggregate your data and to figure out what's going on. So aggregation is the key here. And aggregation is really complex. When you think about tracing, you need to think about what we was usually doing with profiling application. So that set of lines that goes function by function. But distributed tracing is that, but for services. So you trace across the network. So every request that goes to your front line, to your gateway, gets a trace ID. And this trace ID gets propagated to all your system, and your system is able to create their child lines, and you can have a picture of what's going on. So this is how a trace looks like. You can see that I'm really good with colors here. And the list of services you get, and every service has its own span, and you are able to understand how much time you stay in the Nginx, or how much time it takes to the out servers to give you a token, or how many times you call the API or the out service during the chain. Another important step is to understand what's your normal state, how the normal state of your system looks like. And this is not simple nowadays, because you call every servers and they fail, and you need to recover, your containers goes up and down. So says how your services runs in a normal day, it's not really easy. When you get that complex answer, you need to take the picture of the current state, and you need to compare them to see if they are too different. And if they are too different, probably something is wrong. But if they are too different after a deploy, maybe it's not that wrong, or maybe it's too wrong, so you also need to track deploy. So data are really important, but the idea is that you need to understand how your normal state looks like, and you need to figure out the current state and compare them with each other. Instrumentation code is important. As I told you, it's a really good bridge to connect teams, because operational people are interested about the metrics from the application, and developers are very interested to understand what's going on in their application if you put them in charge to understand what's going on and to troubleshoot issues. So it's a good bridge, and this instrumentation code is not anymore a printf that you put in your random controller and you scrape it from the logs. It's way more. So you have logs, you have events, you have tracing, and you need a library that gives you a friendly API to implement instrumentation in your code. There is a bunch of them. OpenTracing is one for tracing. OpenCensus is a project that was open sourced by Google. It's a spec that tells you how you should instrument your code, and there are specific implementation over different languages that you can use in your application itself. So you can use it to collect metrics, traces, and events, and you can inject the concrete place where you should store the traces or you should store the metrics. InfluxDB is a way, but Prometheus is another one. So the idea here is that if you invest a lot in instrument your application, you will have a lot of stuff across it that says, okay, this is a counter that you should increment. This is an Instagram. You should add a point in the Instagram. So all this code should be not tied to the storage where you are storing the data. Because let's say that you're using Prometheus, but tomorrow you need to go to as a SaaS service because you don't have the time to keep it running. So you need New Relic, and you can't miss all your time changing the instrumentation code. So OpenCensus is kind of a layer in the middle that you use to abstract where to go. If you use Prometheus, you know what it is. So Prometheus is a time series database that scrapes metrics from an entry point. And it has counters or gauges or histograms, and you can expose those entry points from your applications and increment these metrics. What I really like about Prometheus is how powerful they made the endpoint that expose the metrics. Because to me, obviously Prometheus gets them and has the gigantic and gives you a lot of capabilities, but this is the entry point that you can use from wherever you want to do automation or to understand what's going on. As I told you before, we have Telegraph, that it's a collector, and Telegraph is able to scrape Prometheus metrics, convert them to point in InfluxDB, or to log in Kafka, or to CloudWatch metrics. So it's a really powerful standard, and the CNCF took it and it is trying to develop a proper standard with the Prometheus community and other companies to bring the exposition format to the next level. This is a function that I pasted from GitHub, and because I like it as an example about the exposition format is very powerful, and you can do whatever you want with it. So it's an API in some way, and this is a function in a application that converts what we saw before to YAML. So it's not very important here, but what is important is not the code, but the idea. So if you need to do a tiny automation, and you don't need complexity, just watch for the metrics by yourself, parse them, and do whatever you want. Let's summarize. There is a lot, but we went over 1 year of our development and operational experience that I try to share in this talk. So I'm gonna try to summarize. Don't be scared to write your code. So if you think that something you need to do is not there, is not your fault, maybe it is, but it can be. So you can be right. So think about how to implement that using the API. Make the instrumentation code a first-class citizen in your company. So when you are developing a new feature and you have a pull request, review the pull request also from an instrumentation perspective. So think about how I'm going to understand when something breaks. Should I have a counter here? Should I have a better logs? Should I have a structured logs? Should I stop to logs as a message that Elasticsearch should tokenize and parse and build a gigantic index? Should I maybe move to a log that looks more like JSON and using tools that can translate that message to a point in time that it's way cheaper to store than a full text search? Keep calm and observe, all together. The DevOps is a very great and powerful cultural change because it's focused about bringing people together, bringing teams together. Because at the end of the story, the goal is one. We are not working in our company because we need to make technology great. We work in the company because we have a purpose, we have a product, or our customer has a product that needs to run, and need to run in a good way. So we are on the same journey, we have the same goal, that it is selling something like if you have an e-commerce, you sell something. If you have a blog, you need to have good context, and you need to make people happy to read in your platform, so whatever. We are on the same journey, we have the same goal, so that's why DevOps, it's crucial, because it develops stuff that helps to take the same path and run to success. So as I said, on Twitter, I'm going to share a bunch of these slides, and there are a bunch of links because, as I said, 1 year is very long, so there is a lot we learn and read and write about this. Thank you.
Guys, if you have any questions, we can ask for.
Yeah. Hello. Yeah, it's fine. The one thing I want to mention that actually open census and open tracing currently merging, so it should be
easier.
It should be easier to
less
implement
confusing.
them. Yeah. And I have one question. What the actual tool do you use to do tracing? Is it Jagger or
we used a lot of stuff. So we started using log as a transport layer. So we created an open tracing tracer that used a logger, and we started to push logs in tracing, in the tracing in the logs, and parse them and push them to Jaeger when we need them, because we wasn't happy to have a storage to manage all this stuff because we was testing. Right now we use Jaeger, and we are gonna, I don't know if I can, but we are working on an InfluxDB backend for Jaeger, so we are using that right now for our stuff. But Jaeger is the main tool.
Thank you.
Thank you.
Thank you. More questions? Do we have some? Maybe in another part?
One over here.
How would you compare InfluxDB and Prometheus in Kubernetes environment? What is more effective?
I really like the Prometheus DNS discovery. So I really like how Prometheus is able to discover stuff in Kubernetes. This is something that there is nothing similar in our stack. We have something similar in Capacitor because we use their same code. So I think it's not really a comparison. We have use cases and I think we're going to use that also. We're going to try it also. We use InfluxDB as a long-term storage. So Prometheus, we see Prometheus as a collector because it is great for that. And when the data are growing too much, we push them to InfluxDB and we query them from there. So I don't think it's right to compare them. It's better to understand where to use them. Both are great. Thank you.
Thank you. More questions? Do we have some? No? Please raise your hands if you have a question. Well, okay.
Don't be scared.
No, we need the microphone because we are making a recording of our speeches.
So my simple question is, how many time do you usually spend for adopting your API systems? When, let's say, Kubernetes API or whatever API is changing, how many time it takes?
I think we mainly use AWS API and Kubernetes API, and to be honest, I never saw breaking changes that took me more than a couple of hours to fix them.
Got it. Thank you.
Thank you. So the API are pretty stable from those kind of projects.
Thank you. Maybe some more questions? Well, it looks like we have no more questions. Thank you very much for just an amazing speech. And